Welcome to Indical Mathematics. I am on the series Indices. In my first video, I did something on simplification. I look at definition and then simplification. In this video, I'm going to look at indicial equation or equation which involves an indices. There are a number of them, but I'm going to take it one by one. We have indicial equation which leads to linear equation, indicial equation which leads to quadratic, one which leads to cubic, and then simultaneous equation, 4 of them. But this video, I'm going to look at indicial equation which leads to linear equation. So let's start. To solve such equations, we use the principle that if the bases are the same, we equate the exponent and vice versa, provided the base is not equal to -1, 0, or 1. So this is the case. That the first one, if the basis a raised to the power x is equal to a raised to the power y, since the bases are the same, we can equate the exponent. So x is equal to y. Or a raised to the power x is equal to a raised to the power b raised to the power x. Here the exponents are the same, so we can equate the base. So this implies that a is equal to b. I have a number of examples here, so we are going to look at how we use this principle to solve them. So the first one, 2 raised to the power x is equal to 32, and we are to find x. Now to solve this, you look for the least base and then you try to express the other one in terms of the least base. The main aim is to make sure that the bases are the same. Now, so with this 32, can we express 32 in terms of 2? So 2 raised to the power x, with this we can write it as 2 raised to the power 5. We have already done simplification, so this should not be a challenge for it. Now the bases are the same. Since the bases are the same, 2, 2, we can say that x is equal to 5. Yes. Let's look at the next one. X to the power 4 is equal to 16. Now, here x and then 16. There's no way that you can express 16 in terms of x or x in terms of 16. But let's think about the question. Here x to the power 4. So you ask yourself, can I express 16 in terms of a number which is to the power 4? So we can write 16 as, so the left hand side, x to the power 4 is equal to, so 16 we can write it as 2 to the power 4. Now the principle is, if the exponents are the same, then equate the base. So this one, x is equal to 2. Now let's look at question 3. 27 to the power x is equal to 81. Now this is slightly different from the rest of the question that we have just solved. Here you can express one in terms of the other. So what you need to do is to, yes, it's true that the bases are not the same and there's no way that we can express one in terms of the other. But the purpose is to make sure both sides are in the same base. So we need to find a number that we can express this, and then 27, and then at the same time 81. Now when we talk of 27, we can have 3 raised to the power 3x, and then 81 too, we can write it as 3 raised to the power 4. So we have 3 to the power 3x is equal to 3 to the power 4. the bases are the same. So what we can do is to equate the exponent. So this implies that 3x is equal to 4. So to find x, you divide both sides by 3. So our x is equal to 4 on 3, which is one whole number, 1 on 3. Let's check other questions. There is another one here, question 4. Now I want you to pause the video. So far so good. What we have solved 3 questions. So pause the video and then try this one. So 3 to the power root x is equal to 9. Now the bases are 3 and then 9. You ask yourself, can I express 9 in terms of the least base, which is 3? Yes, of course. So we have 3 raised to the power root x is equal to 3. 9 can be written as 3 raised to the power 2. So the bases are the same. So it implies that root x is equal to 2. We want to find x. X is under square root. What do? Square both sides. Square both sides. Now on the left hand side, x will be equal to 2 raised to the power 2 is 4. Okay. Now let's come to the fifth one. 3 raised to the power x minus 2 is equal to 1 on 81. Now this one, 3 raised to the power x minus 2 is equal to, from indices, if we have 1 on 81, we can write it as 81 to the power minus 1. So let's look at the base, 3 and then 81. Let's ask ourselves, can we express the bigger number 81 in terms of 3? Yes. So we have 3 raised to the power minus x minus 2, which is equal to 81 can be written as 3 raised to the power 4, all raised to the power minus 1. And now according to laws of indices, there is 4 times minus 1. So we have 3 to the power minus 4. So the bases are the same. So it means that the exponent will be equal. So x minus 2 is equal to minus 4. We want to find x. We send minus 2 to the right hand side. So x will be minus 4 plus 2. So x is equal to minus 4 plus 2, which is minus 2. Let's look at another example, of course, which is the last one. 2 raised to the power 3x minus 1 is equal to 128 root 2. Now, we still stick to the rules. The least base is 2. We can't go further. And over here, we have 128 and then root 2. We try to simplify the right hand side so that we establish that both sides have the same base. So this implies that 2 raised to the power 3x minus 1 is equal to, now we have 128 times root 2, according to indices, can be written as 2 raised to the power 1 on 2. We are not there yet. We have 128, 2 raised to the power 1 on 2. So let's simplify further. So 128, how do we write it in indices? 128 can be written as 2 raised to the power 7, then 2 raised to the power half. On the right hand side, the bases are the same and they are multiplied, which means that we will add the exponent. So we have 2, 7 plus half. So the bases are the same. If the bases are the same, then we can equate the exponent. So this means that 3x minus 1 is equal to 7 plus half is 7 and half. So we have 3x minus 1, which is equal to 2 times 7 is 14 plus 1, 15. So we have 15 on 2. So we have a fraction. So let's clear the fraction. Multiply 2 by 2. So when we do that, 2 times 3x is 6x. 2 times minus 1 is minus 2. Now here when we multiply by 2, the 2 will cancel. So we have 15. So which implies that 6x be equal to 15 plus 2. So 6x is 15 plus 2 is 17. Divide both sides by 6. So x will be equal to 17 on 6. From the blocks, you don't leave your answer in improper fraction. So therefore, 6 will go into 17 2 times. That is 12. It is 17 minus 12 will be 5. So 2 whole number 5 on 6. That is our answer. Viewers, thank you very much for staying with me in this video. If you are watching me for the first time and have not subscribed, kindly click on the subscribe button, and then you turn on your notification button so that anytime I drop a video, you can easily get it.